Hi everyone, this is just a quick video going through a couple of GCSE exam questions on reacting masses because there are a few people who find this a bit tricky. I just wanted to show you how I go about doing these questions. So this first one, we've got this reaction between iron and chlorine, and it's saying calculate the maximum mass of iron 3 chloride that can be produced from 11.2 grams of iron. So it's saying, right, we know how much iron we've got. If I've got 11.2 grams of iron, how much of the product can I make? So this is a useful thing for chemists to be able to work out. Okay? And they've given us the relative atomic masses. Okay? Sometimes they give them to you in the question. Sometimes you have to look them up on the periodic table. But they've given them to us here. So the first thing that we're going to do in this question is work out any of the relative formula masses that we need. Okay? So we need to know about the iron. So we need to worry about the iron here. And we need to know about the iron 3 chloride, because these are the two that have been mentioned in the question. So we can ignore the chlorine here. We're not going to have to worry about that one. Okay. So we already know the atomic mass of iron, so that's done. So we already know this one, so we just need to work out this. So the relative formula mass is given the symbol Mr of the iron chloride. We're going to ignore the numbers that have been put in to balance the equation at this point. Okay, I'm not going to times this all by 2. We're going to come back and look at those numbers later on. Okay, but over here I'm just going to add up, because that's the formula of iron chloride. So we're just going to add this up. So it's going to be 56 plus 35.5 times 3. Okay. So let's just work that out. And it's 162.5. Okay, so that's the first step you want to do. The next thing is we're going to have to use the relationship between the relative formula mass, the mass, and the number of moles. Okay, and this is where it's really useful if you can remember the formula triangle. Okay, the relative formula mass is measured in units of grams per mole, which means it's going to be mass at the top and then moles here. So what do we know? The only mass that we've got is the mass of the iron, the 11.2 grams. So we're going to have to use that, and we're going to divide it by the, or actually in this case, the atomic mass of iron. Okay, and that will give us the number of moles. So we're going to do our 11.2 grams of iron divided by 56, because that's in units of grams per mole. Should probably put the units on here and here. And that is going to give us the number of moles of iron that we've got. 11.2 divided by 56 is 0.2. Okay. Now is the point where we're going to look at the equation and look at these numbers that we've put in to balance the equation. Okay, and again, we're just going to look at these two. We're not interested in the chlorine. Okay, because this is the one we know about, the iron, and this is the one the question is asking us about, the iron chloride. So we're just going to look at these two, and you can see there's a 2 here, and there's also a 2 there. Okay, so we can say that from the equation, there's a 2 to 2 ratio. So what that says is, if I had 2 moles of iron, I would make 2 moles of iron chloride. Okay, well, a 2 to 2 ratio is the same as a 1 to 1 ratio, right? We can just cancel that down. But then I haven't got 1 mole of iron. We've just calculated we've got 0.2 moles of iron. So it's going to be 0.2 to 0.2. So therefore we have 0.2 moles of the iron chloride. Yeah, I just worked out that I had 0.2 moles of iron, and my equation is telling me that however much of this I have, I'm always going to have the same amount of the iron chloride, because it's 2 to 2. You can see that wouldn't be the case for the chlorine. It's not the same, but we're not worrying about that. Okay, so it's 2 to 2, or 1 to 1, or 0.2 to 0.2. Now, finally, we can actually calculate the mass, because now we know the moles of iron chloride. We can go back to our triangle and multiply it by the Mr to get the mass. So now we're going to do the 0.2 moles times by the Mr that we haven't used yet, which was this one. Okay. Just be careful there, don't use the 56, We already did the 56 here, didn't we? We need to use this one because that's the iron chloride. And that's going to give us our answer. So 0.2 times by 162.5. And we get 32.5 grams. Okay. Okay, let's just do one more. So here's a similar question. It's iron again for some reason. But here it's saying we've got iron oxide and carbon monoxide. So we've got this reaction. Calculate the maximum mass of iron. So iron, so we're interested in this one, that can be produced from 300 tons of iron 3 oxide. So it's this one. So again, we're only going to look at these two chemicals. We're going to ignore this and we're going to ignore this. Okay, because these are the two that is mentioned in the question. Again, they've given us the relative atomic masses, so that's good. So that's where we're going to start. We're going to start with, right, we need these two, again, with just iron. So we know the AR of the relative atomic mass of iron is 56. That's easy. And then we need to work out the relative formula mass of the iron oxide. So it's going to be 56 times 2 plus 16 times 3. Let's add that up. And that's 160. Okay, so we're starting this exactly the same as we started the first question. Now we're going to use our triangle that we used before. So we're going to write that out again. Okay, these questions always do the same method. Okay, we're going to do the mass, the MR, and the moles. Make sure you remember this the right way around. Okay, if you can remember the units, if you remember that this is in grams per mole, well then it must be grams divided by moles, right? So it tells you which way around the triangle's got to be. Okay, so now we need to calculate this. What mass do we have? The mass we know about is 300 tons. Now we've got a problem here because this is in grams, but this is in tons. So we should really convert it. Okay. Now there's 1,000 grams in a kilogram, and then there's 1,000 kilograms in a ton. So we'd have to times by 1,000 and then times by 1,000 again. But actually we're not going to bother. Okay, we can cheat here because this is given to us in tons, right? But the answer they want at the end, is in tons as well. So if I convert this into grams, by the time I get to the end of the question, I'm just going to have to convert it from grams back into tons again. So actually, I can just skip that and not bother. Let's just pretend this says 300 grams, and it will actually work out okay, because I would convert it and then convert it back the other way. So we're just going to pretend this says 300 grams, and it is going to work out fine. So we're going to do our 300 is the mass. We need to divide that by the MR to get the moles. Okay, so it's 300 divided by, now we need to be careful, are we dividing it by 56 or are we dividing it by 160? Well, this was 300 tons of iron oxide, so therefore we want the iron oxide, so it's got to be this one. Okay, that's where you need to be really careful, make sure you don't divide it by the wrong number. So 300 divided by 160 is 1.875. So that is the number of moles of the iron oxide. Okay. So now we need to look at our equation. So again, we're following exactly the same method that we did for the first question. I'm trying to lay this out exactly the same. We did the formula masses, then we used the triangle to calculate this. Now we're going to talk about the equation. Okay, so I'm going to do this exactly the same here. Here are our masses. Here's our calculation. Now we're looking at the equation. So this is where we're going to look at the numbers. There's nothing in front of the Fe2O3. So it's telling us it's a ratio of 1. There's one of those to 2. So it's a 1 to 2 ratio. Okay. But I haven't got 1 mole of iron oxide. I've got 1.875. So therefore, the number of moles of iron is going to be double this. I'm going to times this by 2. Is that okay? My equation is telling me every time I have 1 particle of this, I end up making 2 particles of iron. So if I've got 1.875 moles, I should have twice as many moles of iron. So we just need to times that by 2. So we've got 3.75 moles of iron. Okay. Now, finally, the last step is to go back to our triangle. Now that we know the moles, we can multiply by the MR to get the mass. So the 3.75 moles times by, again, make sure you use the right one here. We've already used the 160, so it's going to have to be this one. And we're going to calculate that. 3.75 times 56, and it's 210. Now we would need to be just careful here. Normally this would be 210 grams, but it's not in this question, is it? We talked about tons, so it's going to be 210 tons. Okay, and that was just because we didn't bother converting that, so we don't need to bother converting this, okay, because they would cancel out. Well, hopefully you can see that there is a standard method to this type of question. Okay, they look complicated to start with, but usually from what I've seen with the students that I teach, these bits, most people are absolutely fine with working out the formula mass. Okay, these two parts are just using a triangle for calculation, right? And you do that all the time in physics. You've got, I don't know how many equations for physics you have to learn that involve a triangle. So I think these two parts of the calculation are not difficult. Okay, you just use a triangle the right way around. You must learn that though. This is the only bit where you need to be careful, I think, looking at this ratio from the equation. Okay, so just make sure you're comfortable with what we've done in that step.